ahead and get started here. Welcome to the API conference, or excuse me, the API presentation. We'll go over some details on APIs, risks, all that sort of stuff. For those who don't know me, my name is Greg Sternberg. I'm a security architect working for EVOTEK. Background is I've been doing development or some version of development, architecture, security, privacy, and that sort of stuff for, well, we'll just say over 30 years. With that, I'll let Nick introduce himself.
Hey, thanks, Greg. Hey, everybody. My name is Nick Rago. I am field CTO here with Salt Security. Like Greg come from a development background in the API world. I've been all over the place in terms of from a developer to running engineering teams to I was one of the original employees at a company called Kong, which is one of the largest or the largest open source API management platform in the world. Helped architect and engineer some of the largest digital transformation API management programs really all over North America, anywhere from trading stocks to ordering pizzas online. I've had my hands in a lot of those architectures. I've been at Salt Security for the last couple of years right now, really focused on API security and helping organizations sort of get in front of the challenges that they're seeing today. So excited to be part of this session with you, Greg, and look forward to it.
So with that, we'll dive right into it here. Usually the first question that people ask is, what is an API? Now our speaker at the very beginning there gave a really good definition of an API. And she actually talked about waiters, which I thought was an interesting way of discussing an API. Basically, an API, if you want to get down to its nuts and bolts, is literally nothing more than a function call, a subroutine, some piece of code invokes another piece of code. Now, this API can reside anywhere. I mean, it can reside on a server, in the cloud, on phones, pretty much any piece of technology that can run a program can run an API. I have a really simple example of an API over there on the side there. That's literally all you need to write an API. And if you go up into the cloud using Lambda functions or that sort of stuff, it's actually even fewer lines of code. So this is just kind of an example of how easy, quick, and simple an API is. Anything you'd like to add to that?
Yeah, I think from my perspective, Greg, I think APIs have been around for a while, right? I think from the early 2000s, I think the Salesforce and eBay had, I think the first public-facing APIs. I think that was the year 2000 that those APIs, came out, XML-based APIs. But APIs over the years, and we're hearing a lot about API security today, which I know is the focus of the talk today. And why are we hearing about it? And one of the things with APIs is that especially has changed over these years is sort of from an architectural standpoint, this whole notion of API first architecture. And why security is more and more on the forefront of folks' minds is if you think about, to kind of just build on, Greg, a little bit of what you were saying, is if you think about what APIs are, and in the years past, an API was pretty predictable. It was attached to some monolith. It was in, a castle with a drawbridge and a moat around it. We knew to kind of stack all of our security defenses against it. In the API first world, in sort of the app modernization world, that's completely different. We've had this sort of this advent of microservices, and I always attribute that when we talk about APIs to, think of program functions. In years past, especially if we talk about monolith type based applications, microservices essentially used to be functions encapsulated in some type of program or application code. Today, we're actually exposing a lot of those functions as microservices because we want to reuse them and as much as we can. And the byproduct of that is we're seeing a lot of threats and challenges that we haven't actually seen before with any other architectural application architectures from a security perspective in the past. Specifically, and we'll get into this around business logic. We're hanging a lot of our functional logic that used to be hidden behind applications out in the form of microservices. And again, this has been a major concern for a lot of organizations. So yeah, that's really all I wanted to add, Greg, is sort of why folks are just sort of focused on APIs from an API security standpoint. What's the big deal?
Yeah, and like you said, they're called different things, APIs or microservices or function calls. Matter of fact, I have an example here of one that I wrote from scratch, but they have APIs that access into backend, the old backend COBOL programs. Just to give people an idea of how pervasive APIs are, I've got a couple of potentially slightly dated stats here. API management is a $5.1 billion business. There are 24,471 public APIs. Now, the interesting things here, 80% of web traffic somehow involved an API. So yeah, it's not just the web pages and stuff, because each of the web pages itself is probably 20, 30, 40 APIs in and of itself. 90% of all programs written use APIs. And we'll get into this little thing here a little bit later. 60% of those are third-party APIs. And that's where it can get pretty interesting. As our initial speaker mentioned, now she called it shadow APIs. Here it's called API sprawl, but it's the same general thing. We have all sorts of people, and most people think developers are writing the APIs, or they're done in a programmatic fashion through project management and stuff like that. Unfortunately, fortunately, a lot of APIs are actually written by people that have no programming experience whatsoever. They're not done as part of a software engineering program. I'm specifically thinking of one particular API where somebody from human resources wanted to give his colleagues access to information about the employees. Perfectly legitimate, because this particular HR person needed access to that. So he wrote himself a little API that went into the back-end system. But the problem was, and again, we'll get into this later, that was all it was simply an API interface into it. Let's see, and I'll let Nick talk about the other two here. Kind of touched on the whole business logic one as well, but that's actually a pretty big one.
Yeah, and I think what I also want to maybe just bring up and chat about here is that, from my perspective, and a lot of organizations that I work with today, they're asking, what is a good API security strategy? What does that holistic strategy actually look like? And one of the first things I'll tell them is, if you treat it like a web application, you are going to probably experience some pain at some point, because again, there's different challenges associated with an API. All of those technologies are still important. There's a lot of different disciplines that go into API security, from the testing, that your dev and your scanning and your testing technologies that you're using, and your shield right technologies, your WAF, all of the blocking and tackling that you typically did for web application security, still very important. Capturing and making sure blocking those known badges are very important. But what we're wanting to sort of capture here is, when we talk to attackers, when you talk to folks like that first speaker, I know today was Alyssa Knight, and some other of the white hat API attackers that are out there. One of the things when I'm discussing with them is that they're basically saying attackers are looking for taking advantage of a few different things. And Greg, you mentioned the first one. API sprawl is a huge one. This is a huge problem for a lot of organizations, mainly because, again, before it was the castle, it was the drawbridge, it was one entry I had to defend against. Now, a single business process, or a single digital supply chain for one business function, that could contain calls to 5, 10, 20, 50 different application or API endpoints in that one business function. So there's a lot of different doorways that we have to defend, and API sprawl is a huge issue for a lot of organizations, because again, it's just not that one place. We're dealing with multiple development teams using multiple technologies, deploying their, their piece of the pie, their microservice, their function, and across different various clouds. What's on-prem, what's in one cloud versus another. Again, to the API consumer or to the mobile device user or to the web browser user, you don't know, where all of these, these backend systems live, but the APIs are the sort of the stitching of all of this together. So API sprawl is a big point. I agree with you, Greg. I think one of the things that we're seeing that organizations are struggling with when it comes to sprawl is this sort of notion of, where are all my APIs? Not only where are they, how are they used? What type of data are they handling? And can I vouch from them from a security posture standpoint? Do I know if they're doing what they're supposed to be doing, have the proper authentication, authorization controls in place on top of them, things like that? The other thing that we're seeing organizations struggle with right now from an API security standpoint is the fact that there are a large percentage of APIs that organizations are using are not APIs that they are developing. So they're APIs that are third parties, and I'm bringing them in and packaged applications, open source applications. Greg, you mentioned the point and click, the low code, no code type of now, non-developer developer, right? Who has the power to generate an API just with a couple clicks of a button. And, that is a problem for a lot of organizations in terms of, do I have the right governance to put my arms around that? And attackers know that. That's an opportunity. The chaos is an opportunity where there's sort of lack of governance and visibility. To Greg's point, the other 2 points on here have to do with sort of other shortcomings that attackers are well aware of when it comes to API security. The first big one is for a lot of organizations, there really isn't still nothing deployed that has the context to capture a lot of the API attack patterns, behavior patterns that we see today. A lot of the runtime protection technologies that are in place today, a lot of organizations are using, are still pattern-based, signature-based, or looking at small windows of transaction. So they're looking for known bad behaviors. The problem is every API endpoint has its own business logic and function logic associated with it. So they're unique. Each one is a unique attack interface, if you will. So that's been a lot of struggle for organizations, as well as the fact that attackers know this and they know how to stay low and slow, undetected, and they can do very long reconnaissance campaigns against APIs. And when they find a hole, we just saw with T-Mobile 40 somewhat days before anybody saw 37 million records that an attack was going on. Facebook in a year and a half ago almost was an 18-month breach that nobody knew that was occurring. Again, so just not having the right technology in place has created opportunities for attackers. And then the last thing is, Greg, that you mentioned was around business logic flaws. And I talked to a lot of organizations about this as well, because you have to be cognizant of the fact that application security testing, especially coming things automated testing through the pipeline, is very, very important. Again, they're basic blocking and tackling. I want to scrub out as much bad as I can before things go into production. But with APIs, a lot of the attack types, and we'll talk more about this in a minute, are based on business logic flaws. And these business logic flaws or potentials for misuse of an API are very, very difficult to flush out with automated testing. I have to know a lot about the API, the business function of the API, to understand what's a negative function or a negative behavior or not. And so when I do a lot of talking with folks I know in the DevOps and DevSecOps world, they're basically saying in their pipeline, they're lucky if they're getting 20 to 30% application logic permutation covered with automated testing. So that means when an API goes out the door, there's a whole heck of a lot we don't know from a negative behavior standpoint. And attackers know this. So they know when an API goes out the door that there's a lot of low-hanging business logic flaws that are probably there. And the one thing I always tell folks that I'm working with, organizations I'm working with, is if you're dealing with APIs and you're moving to API first, you have to assume that no matter what you do, business logic flaws and potential for abuse and lapses in governance are going to occur in your environment in production. And attackers are counting on this. And when it does, and it will, and it is, you're only as good as your detection capability. And I know that's Alyssa Knight, who was the first speaker today, talks about this. I've seen her talks previously all the time, is that you're only as good as your ability to detect that something malicious is occurring. So again, for organizations, that's sort of the track I talk about when we talk about a holistic API security strategy. Is I have my short-term play, and then I have my long-term play. What is it I can do now to sort of stop the leak, to stop the leaks in the boat, and what can I do strategically to sort of make the boat better over time? I don't know if Greg, if there's anything you want to add to that, or if that makes sense.
No, it makes perfect sense, and I actually agree with everything you said. Just gonna add two little pieces of sort of developer type context here, because like I said, I'm a developer. And one of them is the API sprawl. And it can happen extremely innocently because, and I've actually seen this, where they had a couple hundred APIs, all was well, they took care of it, that was all good. And then they came out with another version. So now they had, I think it was, we'll just say 300. So they had 300 APIs. Now they have another version, version 2. So now they have 600 APIs. And now they have another version. Now they have 900 APIs because clients were using version 1, version 2, and version 3. They ended up with 6 versions of this. So 6 times 3. It's a heck of a lot of APIs, even if you know where they are and how they're being controlled and all that sort of stuff. Just the sheer size alone was a nightmare. And this was perfect. This had nothing to do with shadow APIs or people doing things that they weren't aware of. It was just normal development cycle where you can't rip out what customers are already using.
Yeah, and Greg, we refer to that as we've typically a zombie API. So an API sprawl, you always hear these terms. You hear ghosts, which are essentially third-party APIs that are out of your governance. You hear zombie, which is exactly what you're saying. Organizations are great at publishing APIs, not so good from a governance standpoint on when to remove the APIs. So we see that all the time. And then the shadow APIs, like you said, and that's where someone gets a great idea. I'm just going to stand this up real quickly, and it's done. We call it, shadow APIs because they're done essentially out of, shadow IT, where I'm out of my basic API governance controls and I'm building an API and I'm publishing it. But yeah, I agree with you. We see that all the time. And we just did a state of security Q3 report the end of last year that we just put out at Salt Security, where we kind of talk and interview a lot of security professionals. And shadow APIs and zombie APIs was the number one concern for well over 50%, over half of all of the security professionals that took the interview. So they know it's a problem and it's something that they're struggling with.
Yeah, and the other thing you run into, and just kind of picks off business logic flaws, and we'll actually see something similar to that in the next screen here. We'll just say developer wrote an API that accepted the numbers, and it was the number of items that was ordered and stuff like that was between 1 and, let's say, 100. All was well and good. So then company wanted something else. He reused that code. But the business logic allowed for 0 to 500. So now all of a sudden you have the same code, 2 completely different business logic flows, and we'll just say one of them broke because the passed in a 0 wasn't expecting it, although perfectly legitimate business context didn't work with the API, problems ensued. So business logic is not just I coded it wrong. It can also be it's being used in an area or in a fashion that the original developer never, not necessarily intended, but never knew about. So these things can very easily slip through development cracks, whether it's even if there's decent architecture and design.
Yep, I agree with you. And I think like you said, the next slide here is a bit of an illustration of exactly what we mean when we say sort of business logic flaw and why it's so hard to detect these things. So this is actually an example of an API attack. You can just pull it back for one quick second, Greg, before we do the highlight. We can see on the left-hand side, we have an API request, a GET, versus a customer's endpoint there with a couple of UUIDs that are showing up there. I can see that I have proper authentication and authorization to use the API. I'm using a JOT token. I can see sort of everything broken out of that JOT token there. Any payloads, cookie information, all of that coming in as well on the request. On the right-hand side, I'm seeing the response come back. So a lot of data coming back from the server, 200 okay. So in this particular case, the customer has in place all everything that they assumed they needed. From I have a WAF that's in place, kind of looking for the known bad. In this particular case, no cross-site scripting, no SQL injection, no code execution attempts in the requests. So nothing that's actually going to raise the flag of a WAF. From an API gateway, an identity provider perspective, both of those are perfectly fine. This is a user that has a token. They have the authority. they're authenticated and they have the authority to use the API. But if you go ahead and click one more time there, Greg, if I take a little, if I look a little bit closer, you can see that here the attacker figured out, wait a second, there is a flaw in business logic here. Even though on the left-hand side, you can see I'm authenticated as that user ending in 277. That's my user ID there. The attacker figured out that, wait a second, this particular API endpoint also uses a cookie in its logic. And I've taken the cookie down below and I've actually changed this user ID parameter of the cookie to something else, a different user ID. Now on the right-hand side, now I can see when I run this request, I'm not getting my data back. I'm getting somebody else's data back. So again, this is a really simple example of something we call Ebola, broken object level authorization. It's #1 on the OWASP API top 10 list. But also this is a great example of kind of showing you how your traditional security stack can miss these type of attacks and why it's so difficult to flush these out. Now, the other thing that attackers, so we've kind of talked about some of the lackings from a tech stack perspective in terms of the tools that are in place and the ability to detect a lot of the attack type and the behaviors that are seen today. So this sort of equates to, okay, so what are sort of the categories of attack that we're seeing today that actually are, that have been fruitful for attackers? What is it that they're looking for? We've talked about the first one already, the sort of lack of API visibility and governance. Where the attackers are taking advantage of APIs whose existence and security posture is really unknown to security. So if you click one more time there, Greg, you're going to actually see Optus is a great example of that. End of last year, this was an example of an API that found the day of light in the outside world with no authentication, authorization associated with it. And Optus didn't know about it, found out about it in the form of a ransom demand. And they're anticipating that this is going to cost them in US dollars of close to about $100 million, 140 in Aussie dollars there. The second category that we're seeing in terms of attack types today, sort of taking advantage of what's lacking from a security tooling standpoint or process standpoint, is, Greg, what you just talked about, this idea of and you go ahead and build that out one more click. This idea of API abuse or misuse, and Greg, this is exactly the example that you gave, where functionally the API is doing exactly what it's supposed to be doing, right? It's taking the request, it's responding back, but the architect or the developer did not consider, well, yes, it's doing what it's supposed to be doing functionally, but can it be misused for malicious purposes? And a great example of this was Peloton had an incident where their bikes were calling to the mothership over an unauthenticated endpoint where they would check in, pull data back from that API, try to obfuscate that particular API endpoint. But an attacker saw that, hey, this endpoint is exposed out there, the bikes are using it, and it is not protecting anyone's data. Rather, if the users had their data on, their profile data, private or not, they were still able to actually pull data through that. We've also seen this through, Twitter, LinkedIn. The FBI InfraGard recently had an incident related to this as well. We talked about business logic flaws a bunch already. Again, there's a reason why this is sort of #1 on the OWASP API top 10. Is because they're so prevalent and it's so hard to detect against and so hard to find with automated security tooling and with the runtime technologies, typically the WAF type of technologies that we're using, most organizations are using today. We saw reports recently from a lot of the car manufacturers where broken object level authorizations or business logic flaws would allow somebody to walk up to a car just by having the VIN number and do things such as unlock the car, start the car. We saw examples with Experian and Facebook, where the example with Facebook was a really interesting one because that was the merging of two microservices or APIs hitting together, a view as API and a video upload API. When massaged a certain way in sequence, Facebook was actually returning the viewed as entities authorization or access tokens, and an attacker was harvesting those for account takeover purposes. Facebook had no idea that logic flaw existed. We've seen this with Coinbase and Experian. F5 is interesting as well because now we're seeing vulnerabilities and breaches related to third-party APIs. I'm deploying these, vendor appliances or these third-party systems in my environment, but I can't assume that they're any better at API security than I am, right? So those systems are just as vulnerable to these type of attacks than as the APIs that we write. And then the last one there, you click one more time there, Greg, and build that out, is one we're seeing, and actually love to get your thoughts on this one, Greg, because we're seeing it so much right now, is stolen credentials and social engineering and spear phishing, and the fact that attackers are basically saying, hey, I'm going to use whatever I can to try to get access to privileged APIs. I want a privileged credential to a privileged API. So if I can get access to your GitHub repository, maybe there's some API tokens in there. If I can reverse engineer, I know Alyssa Knight talks about this in her talks all the time, is she's famous for grabbing mobile applications, reverse engineering, and see if API tokens are unencrypted and manifest that she can kind of latch onto and now get privileged access to an API. So I don't know if, Greg, if you, in your world, you're seeing these, a lot of sort of step up these type of as
Definitely.
well.
The other, especially with, well, actually, example with stolen credentials. The stereotypical easy way for script kiddies is just credential stuffing. In other words, I just try this, try this, try this, try this, try this. And if I have an API and it can be protected, all this sort of good stuff, but if the API isn't and we kind of alluded to this earlier, monitored and watched, what's to prevent somebody from trying enough user IDs and enough passwords to actually find something legitimate? So, it's not just a matter of making sure that the information coming in is valid or not valid, or authenticated or not authenticated. There's also a layer of, threshold checking, quotas, all this sort of good stuff. And I think we touch on that in a little bit here. And then the social engineering piece, we're all familiar with social engineering. It's extremely easy for somebody to crack, well, and with a chat GPT nowadays, you can craft a phishing email that says, I need your, information because your mother's brother's father's something or the other is having issues or they're in jail. So you need to give me this so we can send this money over and save them. Again, take your pick of your favorite social engineering attack. And that gives you legitimate credentials. But that's a situation where looking at it and saying, none of the people that ever use this, or none of the uh, applications that use this are based outside the US. Now we're getting this request for this information and they're based in Romania. Maybe that's not necessarily correct. So there's a whole behavioral piece to this that really needs to be tied into anybody or any company that uses a significant amount of APIs.
Yeah. And the funny thing is, I talk to folks and we're like, well, you think of, grandparents and the elderly folks that can fall for sort of spear phishing and social engineering. That's not the case. They're really sophisticated. Circle CI, Slack, Dropbox. These are all folks in high tech. The targets were folks that you would assume have gone through this training and know not to fall. Don't click that link. Don't do this. Don't fall for that. And they did. So again, it is an attack vector we're seeing a lot. And again, what the question that we ask organizations to ask themselves is, if someone gets a hold of your privileged API credentials, what protections do you have in place to detect that that API that it's accessing now is being misused or abused?
Yeah, because the standard line is it's not a matter of if, it's a matter of when.
Right.
So some things you can do, and I think we've actually touched on pretty much all of this, to be honest. Authorization authentication, and again, Alicia kind of touched on this. Authorization is not the same thing as authentication. They serve two different purposes and they need to be treated differently. I'm authorized to get onto EVOTEK servers and do various things. I am not authenticated to look at HR stuff, as an example. We talked about monitoring and logging. If if you're not watching it and it happens, sort of like if there's nobody in the forest when the tree falls down, did the tree make a sound? It's that sort of philosophical question. You have to be watching. Examining the test code, kind of talked about that. And the last one I'll talk about, and then I'll turn it over to Nick, is asset management. It's the whole shadow APIs, API sprawl, all that sort of stuff. And as most of us know, API management, API, tracking, it's dull, it's boring, it's not very exciting. But, and I think she mentioned this as well, if you don't know that something's there, there's no way to protect against it. because you don't know it's there. So you have to know that everything is there. And APIs have their own little quirk to this. They're so easy to write, they're so easy to produce, they're so easy to put anywhere you want that tracking them down and making sure they're there and monitored and managed is a non-trivial task. So, thoughts on that, Nick?
Yeah, no, I agree with everything you just said, and like I mentioned before, I think it's sort of twofold when people look at, when organizations look at, well, how do I tackle asset management? And I think it kind of folds into the next slide here, if you want to move up, is, first and foremost, I need to know from a discovery standpoint what I have right now. As I mentioned before, it's knowing that the API is there, but also being able to understand what is it doing, what type of data is it touching, what's the security posture actually look like. So there's technologies and tooling, and I come from Salt, and we're big on part of us is what we do is big on the API discovery side, is helping answer that question for organizations. Now then there's the long-term piece of sort of governance and visibility and asset management in terms of how you build APIs. And this is where API governance in the long term becomes important. I don't know how you feel about it, Greg. I'm a big proponent of spec first development. That you don't build a house without a blueprint. So when APIs, we have to be programmed from a governance standpoint to think the same way. I need a specification in place before I write any code. And the advantage of doing this, obviously, is we know that the API is coming. We have some ability to kind of vet it out. Is it going to adhere to best practices from a security standpoint? What type of data is it touching? But I don't want to know it's about its existence after the fact. What do you think about sort of specifications, Greg? I know it's hard to force it right now. It's a big problem a lot of organizations have. How do I get my developers to force them to write a specification before they write anything?
To be honest, it's the same argument we had decades ago with requirements. Used to be people would sit down and somebody would say, oh, I need a accounting system, and they would just sit there and slam out some code over a weekend or over a week, and bang, there you are. APIs are kind of in that wild west arena right now. They're going to have to slow down. They're going to have to go through the same, okay, here's the requirements. The requirements have an architecture component. They have a security component to it. They have a governance component to it. They have an asset management component to them, depending upon the situation. So APIs are going to have to start being wrapped and having requirements applied to them. Otherwise, we're just going to end up with more and more of this as time goes on.
Yep, no, agree. And I think the other part of the important part of the discovery piece is not just knowing that the APIs are there, but what is the risk associated with them, right? Yes, there's an API here. It has no authentication or authorization, or it's using weak tokens, and the data behind it is the crown jewels, right? It's all of our customer data. So it's really important to understand the APIs there with sort of using discovery technology, and also, again, what it's touching from a data perspective, and how it's secured. The other piece is runtime protection, and that's usually the first. Discovery and runtime protection are the two things I tell organizations immediately that they need, right? Again, we need to guard what we already have, using that same assumption I gave before, that whatever we have in production, we have to assume has business logic flaw, potential for misuse, or we're missing some governance and visibility on things that are already in production. So the runtime protection gives you that, in terms of time to immediate value, gives you that immediate value. I can get out there, I can baseline. The advantage we have today versus other architectures in the past is we have the advent of ML and AI. Right? We have the ability to discern user intent based on behaviors. I'm going to learn what's normal about an API, so that if something doesn't look right, I can raise the flag and say, hey, this, someone in the SOC needs to take a look at this. And if you go one more here, Greg, I mentioned this already before. For a lot of organizations, there's sort of the holistic view of API security, but on sort of day zero, what is it I need to do right now? It usually is, the adventure is usually right to left. I need to have that discovery and runtime protection put in place to guard and shield what I have today. Again, I don't want to find out 41 days later that 37 million records were lifted. I need to know on record 1 and 2 that something doesn't look like from a behavioral standpoint. And then on the left-hand side, all of this is important to do. We have this, you hear shift left security come up over and over again. It's done that for client server, web applications, APIs, the same thing. So it's important that all of that blocking and tackling is in place. I still am a big proponent of developer education. Again, constantly, you need to make sure that developers understand what they're coding. And now in the terms of microservices, that it's done in a way that assumes that there is going to be someone that's going to try to misuse whatever they're developing. Spec first development is another big piece of it. Adding API focused SaaS, DaaS, pen testing is important. All of the major automated and application security testing vendors that are out there today, the Vericodes, the Synopsys, the Checkmarks of the world, the up-and-comers like Aperos and Bright Security are all focused on API security in 2023 and beyond. Go to their website. You're going to see a page about API security and what they're doing there. And try to do as much as you can to flush out business logic flaw. This notion of what we call it negative functional testing or contextual API security testing, what we call it, and understanding before something goes into production, I understand that I'm not going to get everything, but I want to have some capability to flush out as much as we can. So speaking, if you go one more here, Greg.
Actually, there's a couple things I want to key off on
Sure,
this slide. Now, those of you that have been with us for the whole time here, you're going to recognize bits and pieces of this. Education, for example, that was talked about by one of our speakers. The testing of stuff. Again, another speaker talked about that. These sorts of things, you look at them, it's like, yeah, that's just standard typical developer stuff. And you're right, that's standard typical developer stuff. The catch is it may be standard developer stuff, but a lot of places don't do all this. Or, they try, okay, they look at it and they say, okay, we'll just focus on API testing and we'll kind of let everything else, take care of itself. This all has to be done, and it does sound like an intimidating approach, but it all has to be focused on. Now, you may decide that we're going to focus on this and then do something else over here. We're going to do continuous API discovery and, this sort of stuff. But this is all interconnected, and any missing piece, frankly, gives a malicious person an opportunity. Yeah. And then that's where, and this is something that's concerned me for a while, is people's ability to get into GitHub repos and stuff like that and look at what the developers are doing, because it allows them to look at things like their test plans and understand that, oh, they focused on this, but they completely overlooked that. So, that's sort of like peeking, in the Wizard of Oz, peeking behind the curtain and seeing who the wizard really looked like. So it's becoming more and more vital that the whole holistic picture be looked at, not just, oh, we can test and don't have to worry about anything else. Or we have a, as Nick alluded to, we have a WAFT, which will solve all our problems. No, sorry, that won't solve all your problems.
Yeah.
So, yeah, like I said, most of this is going to sound familiar to those that have been here and been listening to the speakers, because these are all points that have been touched on throughout this, entire day. So,
but it's confusing because the buzzwords are confusing people, and everybody's talking about API security, from the testing providers, like you're saying, to the the WAF vendors. The analysts are talking about, Gartner changed sort of their WAF category to web application and API protection. So immediately folks are thinking, well, great, I have something in that category. My APIs are covered. And the other thing that when working with a lot of organizations is there's some vendors out there that are saying, listen, we can do everything for you, from testing to runtime protection. And that sounds great for years, from client server, web, and now this. We all want one vendor to go to do everything in the life cycle. Just historically, those vendors have always been an inch deep and a mile wide and leave you at risk. That's why, if you look at this slide in the background here, there is no overlap from application security testing to the runtime protection to the web, to the API gateways to identity providers. Every piece of this is critical, and you need to make sure that you have you're choosing vendors that are masters in each one of those security disciplines. And I just, again, that's sort of my buyer beware, because it's a lot of confusion in the industry in terms of what API security is and what it is, what it isn't. So it's important to bring that up.
Yeah, it's not just one thing; it's a group of things.
This last slide here was just a little bit about salt security and where we fit into all of this. Our claim to fame is we're kind of the let's say the godfathers of API security, and coining that phrase over 5 years ago. We were the first technology that came to market saying, listen, you need you need discovery, you need runtime protection. So we have a technology, we offer technologies that are really best-in-class technologies from a discovery and a runtime protection standpoint. We use cloud scale contextual runtime. The manner in which we do this in is unlike anything else that's in the market today. So our real claim to fame there is that from an anomaly detection, we have the ability to discern user intent better than anybody else in the industry. And this is important because at the end of the day, anomaly detection and ML and AI is not created the same, and can essentially take down your SOC because they are, for a lot of these technologies, if not done right, they become essentially noisemakers. Most anomalous activity is activity that is benign. Someone fat fingered something on a keyboard, developer screwed something up in an integration test that they're doing, right? So having the ability to discern that, really, really important. The other stuff that we touch on as a company is sort of augmenting what's being done on the shift left side. We don't do SAST and DAST and PEN per se because there are 100 vendors focused on API security there that are better well integrated to your CI/CD pipeline and build times and those type of things. Where we're focused on is sort of augmenting what's being done there. OAS and Swagger design specification analysis, again, helping educate developers to use sort of spec first development practices and to make sure that APIs are adhering to best practices from a security standpoint before a line of code is written. Contextual API security testing I mentioned before. The purpose of this particular technology was to really empower the negative functional behavior testing, which is typically done manually. So this particular technology, as your APIs go into staging or go into their sort of testing arenas, sort of learns traffic. And then what it will do from there is formulate attacks using AI, basically play the red team for you so that you don't manually have to do it. Learns the business logic, again, so that it'll try to flush out as many business logic flaws as it can, with the caveat that we know we're not going to capture, and it's not going to capture everything. So that's what we do from the SALT side. And I don't know, Greg, if you had anything else to add, but we have another few minutes, so I'm cool answering questions if anything pops up.
No, that's what I was going to do. I was going to drop over here to the question screen if anyone had any questions, comments, suggestions, concerns, whatever. Otherwise, we can each hit on something to sort of wrap it up here. I don't actually see any questions. All right. Well, in that case, I will let Nick give any last thoughts that he might have, and then I will give what few last thoughts I have, and we'll wrap it up for today.
Yeah, if you're interested to learn more about SALT security, I know we have sort of our virtual booth in the expo, so feel free to drop in there. We have a few folks from SALT security there, happy to answer any questions that you have about the space. Me personally, you can find me on LinkedIn, happy to talk about this and all sorts of other things all day long. So feel free to reach out to me and connect up with me. And I really, really do appreciate the time, and Greg, for you and your time today and having me here.
Appreciate having you, Nick. I think we've probably done a decent job of showing just how complex API security is and how important it is. And there's many solutions out there. There's many ways of solving it. And possibly I'm biased, but I think EVOTEK has a great solutions team that can help with API security. So with that, I will bid you all adieu. And like I said, if you have any questions, reach out to us, and we're happy to talk on this. I'll talk on this as long as anyone wants to listen.
Great. Thanks, everybody.